On a spring day about 65 million years ago, during the Cretaceous period, in what is today Chicxulub, Mexico, a group of triceratops peacefully munch on grass, unaware of the danger lurking nearby. Not far off, a hungry tyrannosaur watches, preparing to strike. But just as it's about to pounce, the predator looks up, startled. Something massive is hurtling toward Earth, a 6-mile-wide asteroid racing through the sky. Little did these dinosaurs know, this wasn't just another day in the wild. It was the beginning of the end. Not only for them, but for more than 60% of all life on Earth. Welcome to The Door to the Universe. We all know the story, how a colossal asteroid wiped out the dinosaurs. But recent discoveries could reshape our understanding of the solar system and Earth's place in it. Newly unearthed evidence about the asteroid's origins have revealed secrets that change our understanding of the cosmos. On August 15, 2024, geologist Mario Fischer-Gödde from the University of Cologne made a groundbreaking discovery. Soil samples from the Chicxulub crater contained high traces of two rare metals, iridium and ruthenium. These metals are mostly found in tiny amounts in Earth's crust, typically left behind by meteors crashing into our planet. Finding such metals in the crater isn't surprising. After all, the Chicxulub impactor was an asteroid. But here's the twist. The isotopic composition of these metals doesn't just tell us what hit Earth. It tells us where that asteroid most likely came from. According to NASA, asteroids are categorized into three types: C-type, S-type, and M-type. First, we have C-type asteroids, short for chondrite. These are the most common, hailing from the outer edges of our solar system, about 520 million kilometers, 330 million miles, from the Sun. They're essentially remnants of failed planetary formations, made up of clay and silicate materials. Then there are S-types, or stony asteroids. These come from the inner solar system, closer to the Sun. They're less common but much larger, composed of silicate materials and nickel iron. Their mineral-rich makeup gives them a bright appearance. Lastly, we have the mysterious M-types, or metallic asteroids. Little is known about these, but they're rich in nickel iron and sometimes even show evidence of melted iron lava flows on their surfaces. Most extraterrestrial objects that crash into Earth are small S-types, about 80% of them. But Fischer-Gödde's study has identified the Chicxulub impactor as a C-type asteroid. This discovery challenges previous theories that Chicxulub was a comet or other kind of extraterrestrial object. Instead, it supports a fascinating new theory that Jupiter may have played a role in flinging this deadly rock toward Earth. Out of all the planets in our solar system, Jupiter has the strongest gravitational pull. It's the largest planet, with gravity powerful enough to hold onto its thick atmosphere of gases and, often, to capture or redirect space debris. This is why the area between Mars and Jupiter has the most asteroids in our solar system. Jupiter's gravity acts like a giant vacuum cleaner, pulling in objects that get too close. So how did this asteroid make the 1,000,000-to-1 shot at Earth? While the exact details are a mystery, we have a clearer picture now, thanks to the new data. Here's how it might have happened. When our solar system was forming, gravity pulled together space rocks, dust, and gas to create planets and moons. Jupiter, the oldest planet, formed around 4.6 billion years ago with plenty of time to grow massive from collecting all sorts of material. Earth, which formed about 500 million years later, was relatively young in comparison. Life on Earth started around 3.7 billion years ago, but dinosaurs didn't show up until about 200 million years ago and ruled for 150 million years until 65 million years ago. The Chicxulub asteroid, a C-type, likely originated from the outer solar system, a fragment of a planet that never quite formed. For billions of years, it drifted through space until one day it wandered into Jupiter's gravitational field. But instead of being pulled in, it was slingshotted toward Earth, setting the stage for the apocalyptic, life-changing event. The impact was devastating, wiping out the dinosaurs and giving mammals the chance to reign supreme. The Chicxulub event is a stark reminder of the lethal potential of asteroid collisions. It's influenced our fears and driven us to monitor the skies for similar threats. That's why the International Asteroid Warning Network exists, to keep an eye on near-Earth objects and coordinate global responses if we ever face another deadly encounter. Fortunately, if history proves anything, it's that we needn't worry too much about a repeat of Chicxulub. Earth is hit by meteors all the time, but they're usually so small they burn up in the atmosphere, ending up no bigger than a rock. But larger asteroids, those are rare. In fact, only 2 significant events are known to have occurred in recorded human history. The first was the Tunguska event in 1908, when a 30-meter-wide asteroid exploded above Siberia, Russia, flattening over 80 million trees over an area of 2,150 square kilometers, 830 square miles. The explosion was as powerful as 1,000 Hiroshima bombs, but miraculously, no one was killed. If it had happened over a city, nothing would have survived. The second event was much more recent. On February 15, 2013, an asteroid about the size of a house exploded 14 miles in the air above Chelyabinsk, Russia. The blast released the energy of 440,000 tons of TNT, shattering windows over a 200 square mile area and injuring 1,600 people, mostly from flying glass. These incidents remind us of what the cosmos can throw our way, but here's the good news. Such impacts are incredibly rare. And better yet, we're getting better at defending against them. In September 2022, NASA successfully completed its double asteroid redirection test, the world's first planetary defense mission. A spacecraft intentionally collided with an asteroid named Dimorphos, which was about 7 million miles from Earth. The impact altered the asteroid's path and trajectory, proving that we can, in fact, alter the course of potential threats. The cosmos is a vast, mysterious place, full of wonders and dangers alike. The Chicxulub impact serves as a powerful reminder of both the beauty and unpredictability of space. But while the odds of another catastrophic impact are slim, about 1 in every 500,000 years, we can rest easier knowing we have technology at our side to protect our planet. As one gazes up at the stars above, remember this: the universe may be unpredictable, but humanity is more prepared than ever to meet such unpredictability head on.